Good morning. Welcome to the next edition of our webinar series. Thank you to everybody taking the time to join us on the session. Today, in particular, I want to talk about manufacturing companies in particular as a focus. That's very much been the theme for us for the month of March this year. And really just delve a little bit into how interruptions in electricity supply affects manufacturing companies in particular. It's no secret that when you are manufacturing a product, electricity supply is critical to ensure that machinery can operate. It's a fundamental component of a manufacturing business. So an interruption in electricity supply is a critical factor. So the topic of today's session is powering manufacturing and how solar can safeguard your business. And as I mentioned, we just want to touch on a couple of things that affect electricity supply that we're currently dealing with in South Africa, and then speak a little bit about how solar as a technology can offer some solutions to consider. So let's get into it. In the South African context today, we do deal with load shedding. It has been intermittent in the last couple of weeks, but most recently in Pretoria, where I'm broadcasting from today, we were reintroduced to load shedding, and it was unannounced, at least on a residential level. And I'm quite confident that this will start to be something which is more commonplace, even in the manufacturing space. And the reality is, if you're not prepared now, when load shedding does become more commonplace and we're experiencing it on a more regular basis, it's going to affect your business and it's going to affect your ability to maintain your income or revenue stream. So some of the implications that we talk about when we see interruptions in electricity supply, we've looked at three in particular for today. The first is operational disruptions. So an unplanned power outage or interruption in electricity supply leads to halted production lines, missed deadlines, and dissatisfied customers. So if you look at halted production, as I mentioned, manufacturing a product, whether it's fast-moving consumer goods, which could be food, related products, it could be anything really. If it's a product that is dependent on a continuous manufacturing production line and that is interrupted, then you have spoiled product. You often have to shut down the whole plant if it's a product which could cause blockages in the machinery. And then you've got the added cost of having to clean all of the machinery before you can start up production again. So an interruption in electricity supply for a manufacturing company that runs these types of risks has a compounded financial impact. So it's not just the loss of potential revenue or income as a result of the interruption in electricity supply and not being able to manufacture that product, but now you have a unplanned and forced shutdown so that the machinery, which forms part of that manufacturing process, can be cleaned. And this often involves time-consuming disassembly, and it just has a knock-on effect, which really increases the financial impact. And that then leads to the next factor, which is financial strain. In addition to the financial impact of production lines being interrupted, we've got rising electricity costs, and these directly impact profit margins, which make it challenging to maintain competitive pricing. Now, there are recent tariff increases which were approved by NERSA, which is really the governing body in South Africa. Eskom, which is the utility provider, applied for these increases and they were approved. And if I'm not mistaken, these increases are going to be implemented for the most part for direct consumers who are supplied by Eskom directly. They will be implemented now in April. And then for customers that are supplied by municipalities, in turn are directly supplied by Eskom, their tariff increases will come into effect, I think, mid-April, towards the end of April. Whatever the case may be, the tariff increases which have been approved, which are substantial, are going to come into effect in April. So you're going to see an immediate increase in your operational cost because your cost of electricity has increased. And there's going to be a potential increase in input costs because every company in the supply chain for your product that you procure at some stage of your procurement process is going to experience the same increase. So not only is your business that is manufacturing a specific product going to experience that immediate increase as a result of the tariffs, the suppliers to your business are also going to be affected. So this is really a compound effect. And at the end of the day, as consumers, if you wear your consumer hat for a moment, we're going to be hardest hit. So everything across the board in the entire supply chain suffers as a result of increases in the tariff. So let's just go back to the operational disruptions. I mentioned halting in production lines and then missing deadlines. So many manufacturing companies manufacture goods or products on a contract basis, which means that there is a deadline for a specific volume to be delivered at a specific time. And if you miss these deadlines, there are most often penalties that are applied because obviously that deadline is in place to ensure that your customer that you're supplying to receives the product timeously, then stocks it into whichever environment they plan to sell it from. And delays in that process also bring about financial implications. So this phenomenon of increasing tariff and interruption in supply just continues to snowball, and it all affects your profitability as a business. And then further down the supply chain, you will end up having dissatisfied customers. So not only will your customer who is purchasing from you as a manufacturing business be dissatisfied and start losing confidence in your ability to meet deadlines and to maintain price points, there will be an erosion of confidence based on the lack of being able to meet commitments based on cost and deadline and everything else. So that all adds to your ability as a business to be able to maintain your competitive price point and also be competitive in your respective space. I'll add it to this to touch again on the halting of production lines. The reality is that some equipment used in manufacturing is vulnerable. So power fluctuations can damage sensitive machinery, again, leading to increased maintenance costs. So we've heard of many instances where machinery is damaged to the point that it needs to be replaced entirely as a result of voltage fluctuations, harmonics. There's a number of different factors that play a role, but it's no secret that in a production line environment for manufacturing of products, if machinery is suddenly halted and it doesn't sort of gradually ramp down or ramp up, whatever the case may be, it can cause damage. So there's so many factors that come about as a result of a interruption, a sudden, unplanned interruption in electricity supply. And these are the factors that we really want to focus on, to bring to the fore, so that we can be mindful and start putting in place mitigation strategies. Now, when considering solar as a solution for your manufacturing business, today I want to talk about two main technology types, if I can put it that way. The first being grid type and the second being hybrid. Now, in both technology examples, the equipment is connected to the grid. So there is a connection point to the network. And in a grid-tied application, this connection point is critical to the ongoing operation of the solar system. So a grid-tied inverter requires a reference of voltage and frequency. And this, by default, is obtained from the grid supply, the electricity supply, the connection point to the network. So when there is electricity available, a grid-tied solar system will be able to start up and operate. The weather conditions then determine the yield or the performance, if I can put it that way, of the plant. So on a cloudy day, you will still have production, you will still have electricity generated from the solar system, but as much as on a clear sunny day. Further to that, temperature also plays a role. So the hotter the surface temperature of a solar panel, the less efficient it performs. The colder the surface temperature of a solar panel, the more efficient it performs. In layman's terms, there's obviously engineering calculations that go into this, but really what takes place is the cell temperature of a solar panel directly affects the voltage output of the panel. So hotter, it drops down, colder, it picks up. So there's many different factors to consider when calculating the potential yield or performance of a solar system. But to come back to the basic functionality of a grid-tied system, you have an inverter, which inverts the DC power coming from your solar array into AC power, which is then usable by your premises, by your building, by your equipment and your machinery. Now, what happens in the event of load shedding, as an example? A grid-tied system, once it loses the reference from the network or the grid, must shut down within a very short space of time. And this is a legal requirement. So if you experience load shedding or there's an interruption in electricity supply, the grid-tied solar system will shut down. So that's one thing to bear in mind when considering grid-tied solar as a solution to your business and your manufacturing application. Now, you might ask, how does this benefit you? Because we're talking about load shedding, we're talking about interruption in electricity supply. Now, you've got the solar solution, but it's not really functioning when I don't have a stable connection from the network. There is a way to get around this. And one of the ways is to introduce or reintroduce the reference required by the grid-tied inverters and the solar system as a whole. And you can do this by means of a generator. So many facilities already have generators in place because of the amount of years that we've been experiencing load shedding. A lot of companies have already invested in diesel generators for the most part. So the great thing is you don't lose the value of that asset. You can incorporate it into your next step of achieving energy security. So you can incorporate your generator into your grid-tied solar system. So if we look at the sequence of events that will take place, you will have a supply of interruption from the network. The generator would start up. Often this could take place automatically. The meters, or the CTs as they call it, or the sensors will, for the generator startup, will pick up that there's an interruption in supply, and it will give an instruction to the generator to start up, and the generator will start up. Once the generator has reached operating temperature and the voltage and frequency is stable, the solar plant, if integrated with the generator, will pick up the reference required, and it will start operating again. Now, depending on the environmental conditions, if it's a sunny day, let's assume it is, the solar plant can operate at its optimum efficiency and deliver maximum yield. What then takes place is, ideally, we want the generator to idle, which at a thumb suck is about 30% of its rated capacity. So when a generator is idling on the mechanical side, it will produce about 30% of its rated capacity on the electrical side. So if it's a 100 kVA or kilowatt generator, if it's idling, it will produce just above 30 kilowatt or kVA. And that's really where you want your generator to be. So it's idling, it's operating efficiently, but it's not working as hard. So ultimately, it is saving on fuel. And then the solar system can pick up the slack in terms of the load requirement from the building. Now, what happens if the environmental conditions change? So if a cloud comes over the solar system, obviously that will affect the yield. The generator then, if integrated correctly and has proper robust communication with the solar system, the generator will ramp up and it will pick up the slack until the cloud, for example, moves away and the solar plant can start producing optimally again. In that scenario, the generator will ramp down. So this is always going to be a handshake process which takes place. But there's many examples of these types of solutions that have been deployed, particularly in Southern Africa, due to the popularity of generators and many grids being unreliable or unstable. So a grid-tied solar system with generator integration is a viable solution, and it will offer you consistent support even in the event of load shedding. Yes, you do have to have your generator running, but because the solar plant is picking up most of the work in an ideal production environment, i.e. a sunny day, the generator will work less, which means in the medium to long term, you are spending less on fuel and your maintenance schedule can be adjusted accordingly. So that's a grid-tied system with the option of generator integration as a first option to consider. That is your most cost-competitive entry point into the solar energy space, while using a generator that you might already have on site and bringing that into the mix to ensure that you can continue to use the grid-tied solar system even in the event of an interruption in electricity supply from the network. Now, the second type of technology is a hybrid inverter. A hybrid inverter has the capability of connecting a battery bank. You can also connect a generator if needed, and there is some benefit to that. And there's quite a dynamic range of functions that a hybrid inverter can fulfill when compared to a grid-tied inverter, for example. So a grid-tied inverter by default cannot accept a battery bank directly. There are ways that you can integrate storage into a grid-tied inverter, but we'll cover that in another webinar. I just want to focus on the two main types of technologies to consider for your manufacturing business today. So the grid-tied with genset integration is the first, and we'll discuss now the hybrid option. So a hybrid inverter is, as I mentioned, very dynamic in terms of its capabilities. As an example, it can accept input from the solar panels. So if the weather conditions are conducive, It will accept the DC input from the solar array. It will invert that into AC, and it will look after the load proportionately. At the same time, depending on the load and the size of the inverter relative to the load, as well as the conditions, obviously, it can simultaneously charge the battery. So if the percentages allow it to do so. So let's put that into context a little bit. Let's assume you have a 100 kilowatt hybrid inverter. Your load, for example, is 50 kilowatts, so that's 50% of the rated capacity of the hybrid inverter, and you have a battery. If the weather conditions are ideal and the inverter is producing at its maximum potential, it can deliver 50 kilowatts to the load, and it can deliver the balance, let's assume 50 kilowatts, to the battery. So it will carry your load and it will charge the battery at the same time. Now, why is that important? Because if you have an operation that has a night shift, for example, you want to be able to access battery storage in the event of load shedding, for example, and obviously at night a solar array doesn't produce because there's no sun, which is quite logical. What then takes place is the hybrid inverter will access the available energy in the battery bank, and it will use that to support the load. If there is a supply from the network available, it can even blend that. And depending on the settings, and there's many different settings and scenarios that you can adopt in a hybrid application, it can prioritize the battery, for example. So let's assume your tariff is higher than your cost of energy from the battery bank. If the energy is available from the battery, the hybrid inverter can prioritize the battery first and use that to support the bulk of the load, and then import from the network, if the electricity supply is available, the balance. So it's an inverter that is very dynamic in its capabilities, and it can be used to strategically reduce your total cost of energy, electricity, call it what you want. And it has capabilities to manage the state of charge of your batteries. So by default, a lithium battery, which is the predominant technology available and adopted today, you do not want to discharge a battery less than 20%. So often you'll hear people talking about 80% depth of discharge. What that means is if a battery is 100 kilowatt hours, you do not want to discharge more than 80 kilowatt hours. So there's always a 20% reserve in place. And that's really just to protect the batteries over the life cycle. Modern lithium batteries have a warranty for the most part of 10 years, obviously depending on the type of product that you use. But all of the products that we supply and install have a 10-year warranty on the battery itself. And it's important that you do not exceed the recommended depth of just discharge from a manufacturer to ensure that you can maintain the warranty over the life expectancy of the battery, which is 10 years based on the warranty. However, if a battery is managed well and it is not discharged beyond its recommended DOD, depth of discharge, and it is not exposed to excessive temperature fluctuations, so too hot, too cold, if it has a stable operating environment, we often see that batteries that are well managed over their life cycle can produce in excess of their warranty. So even after the 10 years, you can continue to use and discharge that battery if it is managed correctly throughout its life cycle. And then, as I mentioned earlier, you can integrate a diesel generator with a hybrid system. And why would you want to do that if you've got the batteries available, for example? So let's assume it's a cloudy day and you haven't been able to charge up your batteries to the desired state of charge, and you experience load shedding, or you are anticipating load shedding to take place in an hour or two, and you know that you need a specific amount of energy from the battery bank. Once your battery gets to a specific preset state of charge, you can integrate a generator to come online if there is no electricity supply available from the network to charge up your batteries. So a hybrid solution is a dynamic solution that can offer you a few layers of redundancy so that you could plan accordingly to meet any circumstance, so to speak. And everything is relative to the design, obviously, and then the application of the system. Making sure that your system is designed and installed and set up in terms of its functionality to address your requirements with regards to your load and when you use electricity and everything in between. So those are the main two sort of technology types that I wanted to touch on today. Is your grid-tied applications, just so you have a little bit more information and you know what to consider when looking at a grid-tied system. There is a way to bring on board a secondary reference so that that system can operate even in the event of a electricity supply interruption. And as I mentioned, there are ways that you can bring on board storage, even if you have an existing grid-tied system. And please reach out to us if you have and you want to talk about bringing on board some storage for some battery storage for your facility. So what are the benefits as a manufacturing business when considering solar and the solutions that the technology offers? So one obvious one is energy independence. So you get to maintain your operation seamlessly, even during grid failures, taking note that the system functionality, how it is designed and integrated is critical for this to work correctly. You have more cost predictability. So once you know what your levelized cost of energy is, and that is calculated based on a couple of different factors. But let's say, for example, you install a system. We use the capex value of the system or the plant or the project to determine a levelized cost of energy. And this is calculated by the cost of the system. If you're integrating a generator, for example, what the cost per kilowatt hour of the generator component would be. And this is based on operational cost and fuel. So fuel increases more often than it decreases. And this is factored into the levelized cost of energy, your battery and everything else. So once you have a levelized cost of energy based on your solution, you can compare this to the current tariffs, and that the levelized cost of energy that is brought on board as a result of your solar system and the integrated technology allows you to have a much clearer outlook and perspective on your costs, and you can forecast much further in advance than you can now, because we never know what percentages of tariff increases are going to be implemented and approved beyond 3 or 4 years from now. It's always a gray area. Whereas if you have your own energy security solution, this is much more predictable. You can mitigate the impact of future tariff increases, which speaks to the predictability, and your business on the whole is much more sustainable. So your operations are more consistent. You can manage your input costs better. You can manage your manufacturing costs better. And you can ensure that you're meeting those deadlines and you're maintaining customer satisfaction, which are some of the points that we touched on earlier. Now, you might ask yourself, why choose Bigfisch? Well, we do things a little bit differently to many other businesses, but just to keep things simple, we start the process of project development at the feasibility study stage. So we look at the holistic picture of your business. We come to your site and we do a site assessment, look at various surfaces available where solar panels can be mounted, look at placement of major equipment like inverters, batteries, generators, whatever the case may be. And this all forms part of a feasibility study. Now, in the early stages, we can do what we refer to as a desktop feasibility study. And all that we require in this regard is 12 months billing. That allows us to get a good idea of your annual energy consumption, the tariff that you are paying, and any ancillary charges which are being incorporated into your bill. And there are often opportunities to address those ancillary charges, whether you are being charged a maximum demand fee. Now, this is a fee that is included in your bill if you exceed your supply capacity, and businesses that we've supported with solutions that we've seen are heavily billed when it comes to maximum demand in particular. And the thing about maximum demand is even if you exceed your threshold for a very short period of time, once that month, that demand charge is included in your bill, and it's a hefty charge. So we can address these things. Engineering, procurement, and construction. So the EPC part of the business, we fulfill. We are direct importers of equipment from all of the leading manufacturers for the energy space. All of the products that we import, supply, and install and support are tier 1 products. So tier 1 in a nutshell is really just a name tag that's given to a responsible manufacturer that is bankable in terms of their business operations, their sourcing of raw materials, and their ability to support their product that they supply on an ongoing basis. So tier 1 is something very important to look into. Project development and financing. So we can assist in developing the project from the ground up, looking at different design options, different technology mixes to meet your budget and meet your application. And again, this can be done in phases. Often people or companies can't afford to fulfill their complete requirement all in one go. And we can guide you in breaking up the entire solution into different practical and manageable phases, which we can then integrate over time. And financing is an option available from us. So we can finance the projects that we're involved in and that we install, commission, and support. And then after the fact, so what happens once your system's been installed? What do? Well, we come on board and we offer you operation and maintenance support. If you've ever heard the saying that solar is maintenance free, it's not the truth. Solar is a working asset that needs to be maintained meticulously to ensure that it can perform at its best. So like a vehicle, for example, you want to make sure that you're always servicing it regularly and making sure that the fuel consumption is as expected, so that the power output and the power delivery is at its best. It's the same for a solar system. You want to make sure that you are looking after the solar plant, getting involved and addressing any issues that come up, and just making sure that over the life cycle of that system, you are getting the most out of it. And that's really it in a nutshell. Just touching very lightly on 2 technology types that you can consider if you're in the manufacturing space that can have immediate impact on your business and allow you to remove this gray area of uncertainty as a result of load shedding and failing infrastructure and just general electricity supply interruptions as a result of so many different reasons. Take the power back into your own hands, take the first step towards energy security, get in touch with us. Let's sit down and have a look at your needs and see how best we can support you to address those needs. Please contact us for more information. This recording will be available once we conclude the webinar. We have our office number on the screen, so it's 010-500-254. Please come and visit us at our offices in Meadowdale, Johannesburg, where we have admin as well as warehousing. We keep stock of products that we integrate into our projects, so we can really bring about some short turnarounds for our projects and make sure that we get you the right solution as quickly as possible. Feel free to send us an email at info@bigfish.co.za. I look forward to hearing from you and assisting you and your business in moving towards a space where you can control your energy and electricity supply and the costs looking forward. Have a good day.